goodness of Mr. Toops, it's a great day, beautiful Saturday, and I'm making these videos so you can learn with more power. Today, we're going to have a blast. We're going to talk about direct variation. That is algebra term for proportional. So in 6th grade, you spent about half of the year talking about proportions. Now we're going to call our equations that are proportional, they're going to be called direct variation. Instead of making two fractions equal to each other, we're going to write it kind of different, but it's the same process. So we're going to learn about direct variation again today. We're going to learn how to write the equation and how to solve for direct variation problems. Oh, it is going to be fun. So let me start recording, or it doesn't happen, like I've done that twice today. So recorded this computer, and we are recording. So let's get going. Notice that this has some notes on it because you haven't heard of direct variation before. Okay, if you take this table and divide any y by x, so right here, do y'all see how I'm just dividing y by x? Okay, so I'm putting y over x, y over x, y over x every same time. If you do all of those division problems, you always get 3, don't you? Okay, that number is called the constant of variation. The constant of variation. Oh, that's like more power. It's like, guys, you go like, I think I'm the constant variation of your date life. So like, try to get out, get a good vibe there going. Constant of variation. Okay, now then, this is important right here. This is how you write direct variation. So direct variation will be y equal kx, and the k is y over x. Okay? So that's how you write direct variation problems. In this problem here, the equation would be y equals 3x, wouldn't it? If you take any x and multiply it by 3, you always get the y. That's proportional, right? Also remember that this does not have a starting number, right? The y-intercept is 0. This will graph a line that goes to the origin, just like you learned in junior high. Lines that go through the origin have proportional table of values. Same process right here. This top part talks about all those definitions you need to know. Now then, on these problems here, if it's y equal kx, it has direct variation. There is no starting number, right? No starting number or no y-intercept, right? So in this right here, remember we have gx plus s equals total. You're just going to have the total equal gx, okay? So you're just going to have a number equal the kx. For instance, on this one right here, we need to figure out which ones have direct variation and figure out what the constant of variation is. So on this one, if you divide by -8, you'll get y equals -1 over 4x, k equals -1 over 4. Piece of cake. Now then, look at number 2. Number 2, this right here would be our y-intercept, right? Or our starting number. This does not have direct variation. So write down no direct variation. Okay, so if a problem has a constant, it does not have direct variation. Look at number 3. Do you see any constant like the 5 on this? It doesn't. It just has the x and the y. This will have direct variation. So we're going to separate and we're going to solve for the y. So we'll get y equals -12 over 36 is 1/3 x. And the k would be -1 over 3, right? So this would be a line that goes to the origin. See if you can do the bottom 3 by yourself. I'm not going to eat all your Oreo cookies, okay? So let's go to number 7. On this one right here, we're going to write the equation and then we're going to make x equal 8. So put y over x. That's what we're going to do. So write down y equals, y over x would be 10 over 2, wouldn't it? 10 over 2x, which would turn into y equal 5x, wouldn't it? Okay, so on this problem here, our k would be 5. Our constant of variation would always be 5, which means if you multiply any x by 5, you'll get your y. So we're going to do y equals 5 times 8, and we would get 40, wouldn't we? Oh, fun stuff. So you're just going to put y over x and then plug in 8 for x. You'll always use x equal 8, and I'll do one more for you. So put y over x, and we would put what? 6 over 18, would we? So write down y equals, y over x would be 1/3 x, right? And then we're going to take x and we're going to replace it with 8. And this would turn into 8 over 3. Oh. So that's all you're doing right there. Put y over x, make the equation y equal kx, plug 8 in for x, and see if you can get your y. Turn the page! And these are proportion problems. And we're going to set this up not with a proportion, but in direct variation. And notice I give you the y and x each time. So on the problem, Bubba Bob earns $16 per hour working for Silsbee Septic. That's a manly man job. Write a direct variation equation where y equals the amount of money earned and x equals this is what your y is and this is what your x. So y is the dollars and x is the hours, right? Okay, then find the money for 2.5 hours. Now then we're not going to make a proportion here. So write y equal k over x, right? Then you're going to put y equals, and it's $16 per hour. So we're going to put 16 over 1, and then we're going to multiply that by 2.5. So the y right here is 16 per hour. That's going to be our x, and then we want 2.5. That will go here, won't it? So you'll just do 16 times 2.5, won't you? So y is going to end up equaling 32 plus half is 40. So he'll get $40 for 2.5 hours of work. Okay, and we'll do one more problem like this. Let's go down to 15. Okay, so Lucy Claire's making cornbread. Eat that with some beans and rice and you got supper. Okay, for every cup of cornmeal, for every 1 cup, it takes a ½ cup of milk. Okay, write a direct variation and notice I'm telling you what y is and what x is. So the y is the milk, so for 1/2 would be our x, and x would be the amount of cornmeal, which is 1 cup, right? So write down y equals y over x, and then we're going to write down y equals, and then our y would be 1/2, and then we're going to have 1 cup of milk, right? You could put 0.5 up here if you wanted to. That might make it simpler, okay? And then we want to get 3.5 cups of cornmeal, right? Which is going to be our x, right? So basically you're going to do 1/2 times 3.5, and you would get, just punch that in the calculator, you end up with 1 3/4, or 1.75, or 1 3/4, or 7/4. If you kept it as a fraction, it'd be 7/4, okay? You can turn those into decimals, make it a little bit simpler. And let's finish up. Let's go to number 17. Okay, the same thing here. So you're going to put, you can pick any one of them. So let's do this one, and I got to let my cat out. Hold on. Jiminy crickets. Okay, we're back. Okay, so I would just pick the first y over x, and we're going to put 3 over 2x, right? And then you're going to solve for x equal 8. So y equals 3 over 2 times 8. And if you did that, you would get 24, you would get 12, wouldn't you? Okay, so you're just going to make your y equal y over x. That's going to be your k. And then you just plug in 8 for x and finish up the problems. So today you've learned about direct variation. Direct variation is when you put a number varies directly with another number, and usually we're going to use y and x because that's the coordinate grid. When you do that, the y over x turns into the letter k, which is your constant of variation. And then you can replace x with a number to find the given value. That's basically what you learned today. And remember, these will graph lines that go through the origin. Remember, you are amazing. You are due to wonderful things. You are born to do wonderful things, and you are awesome.